Hey there, science enthusiasts! My name is John Michael Tapia from Gold. Today, we're diving into the fascinating world of collision theory and how it impacts the rate of chemical reactions. So, what exactly is collision theory? Let's break it down in simple terms. So, what is collision theory? This is where the particles reacting, they have to collide with each other with sufficient energy, also called activation energy. Of course, kung walang energy, there's no collision at all. And to sum up about an entire reaction, which involves tons particles, then the rate at any particular point is going to depend on two main things. First, the amount of energy the particles have. The more energy they have, the more they can transfer during the collision. Second is, the other important thing is the frequency of collisions. It means how often the particles collide with each other. So even though not all the collisions are successful because the particles involved don't always reach activation energy. The more often they collide, the more successful collisions they'll be overall. Now, let's talk about what affects the rate of these chemical reactions. There are a few key factors at play here. First up, we have concentration. Think of it as the crowd at a concert. The more people packed in, the higher the chance of bumping into someone. Similarly, the higher concentration of reactant molecules, the more collisions happen, speeding up the reaction. The second one is temperature. Heat adds energy to molecules, making them move faster. Just like how a dance floor heats up as the night goes on, raising the temperature increases the chances of successful collisions between molecules. What about surface area? Ever notice how a powdered substance dissolves faster than a solid chunk? That's because of surface area. Breaking a substance into smaller particles exposes more molecules to potential collisions, making the reaction happen faster. How about catalysts? Catalysts are like matchmakers for molecules. They lower the activation energy needed for a reaction to occur, speeding up the process without getting consumed themselves. It's like having a wingman at a party, making it easier for molecules to find each other and react. Lastly, the nature of reactants matters. Some reactions are inherently faster because of the types of molecules involved. For example, reactions between smaller, simpler molecules tend to be quicker than those involving large, complex ones. And there you have it, guys! Collision theory and its impact on chemical reactions explained in a nutshell. Remember, whether it's in the lab or in everyday life, understanding how molecules collide helps us make sense of the world around us. Stay curious and keep exploring. Again, this is John Michael Tapia from Gold, and thank you so much for listening. God bless you all. Thank you.